it's 6:05. I've waited for 5 minutes. Looks like there are not too many visitors, so I'll start with the session. So, welcome to the NPTEal session for the course Nanobiotechnology Enabled Point of Care Devices. The course code is NOC24G23. This is the second live session. The course instructor for this course is Professor Gorchan Datta from IIT Kharagpur. My name is Amit Dukle. I am Prime Minister's Research Fellow in the Department of Mechanical Engineering, IIT Tirupati. So I'll be the mentor for this course. So before we begin, just some important points. This is a live interaction session to boost your performance in the exam, to give you an idea about what type of questions will be coming in the exams. It is not compulsory, but we highly encourage you to attend them. We request you to be respectful in the chat. The questions and all your doubts can be asked at the end of the session. If you have doubt regarding a particular question, you can just unmute yourself and ask your question. Videos will be uploaded on YouTube. This is the YouTube channel link, and you also found the a public sheet which has the course material as well as the YouTube channel link. So that's there. So since we are done with the basic things, let's go to the session plan. So today we'll be discussing the practice assignment 2, and then we'll be keeping it open for your question and answers. So coming to the course, this is a 8-week course and we are in the second week. So this week it is the syllabus involves biomaterials fundamental concept, nanomaterials for early stage biomarker detection, synthesis and characterization of nanoparticles and their use in biosensors and biodevices, biofunctionalization of nanomaterials, beneficial properties of nanomaterials for diagnostics. So this involves these important things. So we start with the week 2 practice assignment. So coming to the first question. So basically you are being given reaction per se. Here you have a analyte being detected by the primary antibody. Then we have a labeling antibody with a labeling element. Then you have a redox reaction. Basically redox reaction, as we found out, are being used to amplify the signal so that the signal can be detected quite easily. So here it's from this redox reaction we are basically in this question we are supposed to find what are the starting materials. So we are given some options. So these are your options. So TCP, the reduced state of TCP, AN, NQI, AN with gold nanoparticles, rudium in its two oxidized states, +3 and +2. So we have to find out which are the starting materials in this reaction. So any guesses? No, actually the answer is D, that is 1, 5 and 6. So here the starting materials, you have to understand first starting material is TCEP, because that is coming that is giving away electron and then going into its oxidized state of TCEP. Then the second is gold nanoparticles of AGP. So basically, from gold nanoparticles, they are reacting with the the labeling element on the secondary antibody, and it is converted into AN. So AN is the second starting agent, and the third is rudium in its rudium 2 plus. So basically, these are the starting elements in this reaction, because you can see that uh, from these particular materials the reaction is starting. So the ANGP, you can see, is from which the entire cycle is being starting. So ANGP is basically, you need to know, it is very it can be clearly seen from the figure. Then TCEP, again it's a reducing agent. It is the main reducing agent used in many reactions. So TCEP is the also this is starting material. And here, since rudium, basically we want rudium to give away electron so that we can get the reaction, we can actually detect it. So basically rudium 2 2 plus is what is the starting material. So I hope I am clear with this one. So we move to the second question. Which of the following is a correct representation of a lateral flow assay? We have the first option wherein we have the working electrode. The labeling elements are on the reference electrode, and the secondary labeling elements are on the counter electrode. In the second representation, we have the secondary labeling elements before the working electrode, the detection antibodies on the working electrode, the reference electrode and the counter electrode are blank. In the third as well, we have the secondary labeling antibodies, but here we don't have the other labeling elements in this. So we have the sample. We don't have any other labeling materials. We would directly have the secondary labeling antibodies, the primary identification antibodies on the reference electrode, and the working and the counter electrode. In the fourth option, we again have the sample pad. Then we have the labeling elements. Then we have the primary labeling and secondary labeling antibodies on the working electrode, the primary identification antibodies on the reference electrode, and the blank counter electrode. So any guesses? See, basic when you are having a lateral flow assay, the working electrode you have to understand from the last lecture is where the detection actually occurs. So from this figure you can identify that the primary identification is the primary identifying antibody. So that is only present in option uh, B and C. So from that, can you take a guess? So detection will happen at the working electrode itself. It will not happen at the reference or the counter electrode. So from that, can you take a guess amongst B and C? Okay, so the answer is B. So in this, you can see that the sample is taken on the sample pad. Then the other components that are like TCEP, ANGP, and rudium, which are basically very useful in a redox reaction, will attach to the analyte elements. Then to the target analyte, the labeling antibody will attach, and then they will the entire mass will be taken over to the working electrode, and the working electrode will identify it. In case there is the analyte is absent, in case of negative result, the entire thing will just move on, and you will see in the control zone, you will see a reaction, you will see some colors from these labeling antibodies and the other labeling elements for the redox reaction. That you will see some color, and that will confirm that the test is working, only your result is negative. So the entire detection will only happen on the working electrode. So for that, whenever you are seeing anything, the main detection that will happen by the primary antibody will happen at the working electrode itself. So keep that in mind. Any questions? You understood, right? Okay, I'll take it as a yes. We'll move to the third question. Okay, so this is a very basic question. Common drawbacks of current medical diagnostics are it's laborious, it's handling of large volume, less consuming protocols, complex and single step, trained personnel, miniaturization ability. So from this you can basically anyone can identify this is a multiple select question. So you have to select more than one option. So any guesses? This is I'm expecting answer for this one at least. your your first and second answer are right. The last answer is not. So basically, you can see that yes, the current medical diagnostics are laborious. That's the right answer. It it needs large volumes of blood. So basically, if you see normal, whenever you go to give blood test, you will at least need to give the entire syringe. So maybe it might be 2 ml or 3 ml or 4 ml. But if you see the glucose detector that is used for major for the diabetic people, that requires just a prick. So one drop of blood is more than enough for those kind of detectors. So you can see that that is the main drawback. So here where you need 2 ml and the other place you need not more than 300 microliters. So that is a lot of difference. So yes, it is a main drawback. It is not less time consuming. It takes a lot of time to actually get the result. So it is not less consuming. So that's a wrong option. Then it is complex in single step. No, it is complex, but it is not single step. It takes more than a lot of steps. So basically, if you are doing a blood culture, so basically if you have some bacterial infection in your body and you need to find out what bacteria it is in your body, so what it will first do is first they'll take out blood from your body, then they will put it in a basic non-selective media. So basically they'll take in a media where all type of microbes can grow. So that is uh, where the that is the first step. So after 12 hours they'll find out whether you have bacterial presence in your body or not. After that they'll put it in, if you have bacterial presence, then they'll put it in selective media. So basically media in which only specific microbe will grow. So it takes more than one step, basically a lot of steps to actually arrive at the result. So that is also not what is the characteristics of current diagnostic method. E you require trained personnel. Only trained lab technicians can actually do the tests inside the lab, whereas taking the example of again a glucose monitor, anyone can do. Me, anyone can actually do the this testing with the point of care testing devices. Miniaturization ability, basically this is not many people know about it. So basically miniaturization ability is basically the ability to shrink everything into one. So if you can shrink a thing, so basically as you may know, the computer in the 60s would actually take one entire big room, but nowadays the computing power of your mobile phone is more than that computer in your 1960s. So that is what is called as miniaturization. So you can miniaturize, you can shrink it, and keeping the functions intact. So that can't be done because current diagnostic, the equipments are so big, you cannot actually shrink them into a small place. So the answer is A, B, and E. It is laborious. Uh, it requires large volumes of samples, and it requires trained personnel. Any doubts with it? So moving to the next question. So here you have to recognize which is the correct redox reaction. So you have here four reactions on that are occurring, and you have to find out which of the following is correct one. So all the reactions are looking same. You can see the in the first in the the products, and the elements involved are the same in all the reactions. So that is not what you will realize. So s- uh, so just look. Let's go option by option. So in the first option, we have oxidation reaction from TCP, basically TCP to the reduced form of TCP, and a reduction reaction in the bottom. So in this case, basically, what do we actually want from the, what is the purpose of redox reaction to occur? So basically, can anyone just say why we are doing this redox reaction? Like, what will be the main fundamental reason for doing for having this redox reactions in our sensor, basically? So basic fundamental thing is we need the reaction to release an electron. So the main reason from why we are doing it is to release an electron. So release of electron happens only in oxidation reaction. It doesn't happen in the reduction reaction. So from that, if the bottommost reaction is the reduction reaction where the electron is being taken up, it cannot actually release an electron and give out a signal. So the option A and D are wrong because there is reduction happening, which is not what we want. Reduction is taking up of electron. We actually want it to release an electron. So answer option A and D are wrong. So now coming to option uh, B. So here you can see there are only two oxidation reactions. There is no reduction reaction as such occurring. So in this you can see that redox stands for reduction oxidation. So here it is, you can obviously it is wrong. So from the when the last three are eliminated, let's go to our answer. That is answer is C. So oxidation, basically we need the release of electron to occur at this at the electrode. So we have the oxidation reaction at the bottom and the reduction reaction at the top. So even if you don't go into the basic kinetics and the fundamentals from uh, the lecture, just understand one thing is that at the electrode you want the electron to be released. So from that logic itself you can deduce something. So you understood what I said, the technique with which we can do these equations. In case you are so because many times it is very difficult to remember every byproduct and remember every reaction. So using this technique, at least you can solve the answers in a better way, in a more accurate way. So that is why I'm teaching you that way rather than going into the fundamental reactions and everything. I'm just teaching you the fundamental purpose of the reaction, and then why, how we can identify which is the right reaction. So I hope this this approach is helpful to you, and it can help you in solving some of the complex questions, because in exam there might be another reaction that might come. So from this approach, at least you know what the fundamental purpose of this redox reaction is, to release the electron. So from that, you know that the oxidation reaction has to come at the bottom, then the reduction reaction will come. So in the redox reaction there will be a reduction in oxidation, and because the we are releasing an electron, oxidation will come at the bottom. So I hope this was a good explanation to help you with. So we move to the next question. So this was basically, this was given in the class. So this is just what is the full abbreviation of TCP? Trace 2 carboxy ethene phos, phos, phosphine. Trace 2 carboxy ethylene phosphine, tri carboxy ethyl phosphine, trace carboxy ethyl phosphine. So any guesses, or anyone knows the answer? So I'll only give out the answer. So basically this is trace 2 carboxyethyl phosphine. So this is the chemical structure. This is a very important chemical in the biosensing application. This is a reducing agent. So I would recommend you to know about this, and also um, just keep the structure in mind, so that might can also be used in your exam. So just keep the um, name of the full form of the chemical, and the chemical structure in your mind. Just keep it in your mind. That would be helpful to you. Any doubts? So we move to the next question. So basically we want to find the redox couple for 4-nitrophenol, hydrochloroquine, benzoquinone, catechol, and resoxinol. So basically these things are there mentioned in the lecture. You need to watch your lectures carefully, because all these things, all these reactions are actually covered in the lecture. So we'll check whether you have actually seen the lecture or not. So anyone has your answer or questions? see any answers, so I'll I'll only give out the answers. So yeah, it's a multiple select question. So basically, when it is oxidated in presence of a catalyst, we get hydroquinone and benzoquinone. These are the two couples for nitrophenol. So moving to the next question. So yeah, as we discussed, glucose monitor so much time. So here it is. It's a reaction of glucose with glucose oxidase forms D-glucono 1,5-lactone, gluconic acid, hydrogen peroxide, and gluconoic acid. So we have discussed this a lot of times. So anyone knows the answer? Okay, so a hint. It's a multiple select question. So we discussed this reaction last time as well. So basically, the glucose sensor has a platinum electrode at which the sensing actually occurs. So then there is a semi-permeable membrane, then there is glucose, and then through capillary action, basically the blood comes. Then there is a coating of glucose oxidase. Then there is a semi-permeable membrane, and then there is a platinum electrode. So at the platinum electrode, hydrogen peroxide is oxidized to H2O, and it loses out the electron. So that is something which is the main what we can say is the detecting element. So now again there will be other two materials that will be coming in. So basically, in presence of glucose oxidase, so glucose transforms to gluconolactone, as well as it uh, uh, produces gluconic acid and hydrogen peroxide. So main thing what we are detecting basically is the quantity of hydrogen peroxide. So basically, more quantity of hydrogen peroxide is produced, the more the glucose concentration is there. So what we are detecting is the hydrogen peroxide, but glucose obviously has to uh, transform into material. So we get three answers. Gluconolactone, as well as um, gluconic acid and hydrogen peroxide. So this is how the reaction actually occurs. You can see the reaction. doubts, any questions? Okay. So moving to the this question 8. So yeah, so actually this is the compound here is an is basically in presence of ALP it is producing two products, so we have to identify the two products are. So basically in this, even the name of the compound is not given and the name of the products is also not given, so you have to be very um, like strong with your chemistry basics. So I'll just ask you, do you guys know what the name of this compound is? The name of any of like the compounds or even the full form of ALP? Anything you can give out. Yeah. So these are the type of questions that will come in your exam. So be prepared. Try to, as much as possible, try to understand the concepts as well as like these fundamental reactions. Something you try to remember and uh, try to get it, maybe write it somewhere and just try to go through them before the exam. And as I said, use the elimination technique. So as I told you, but in terms in chemistry, like very fundamental chemistry equations, the elimination technique won't work. So basically, in terms of like some of the other questions, try to use the elimination technique, but also try to learn your fundamentals quite clearly. These are everything here has been given in the slides. Many times it is not visible in the lecture material, so you have to go through the lectures videos per se, because the lecture slides don't contain everything, but this reaction has been given mentioned in the lecture video, so keep that in mind. So go through the videos once, maybe pause them, write the reactions what sir is writing in the um, um, during the lecture video, or else just take screenshot. But I would say suggest always I would suggest writing them down. I'm not seeing any answer from your end, so I'll just go ahead with the answer. So basically, this is aminophenol phosphate. So basically, aminophenol phosphate is the um, starting chemical. So ALP basically is there in the labeling element. So basically, the labeling antibody is conjugated with ALP an enzyme. So in presence of ALP, it forms aminophosphate, and then aminophosphate also undergoes some reaction and forms aminoquinone. So these are the two byproducts of this reaction. So basically, from aminophenyl phosphate, we in presence of ALP, we find aminophosphate as well as aminoquinone. Any questions, any doubts? Okay, so I'll move to the next question. So in which form of methylene blue is blue? So oxidize, reduce, neutralize, all of the above. So this is kind of a trick question which can confuse people. So what do you think it will be the answer? Any guesses? So any guesses for this question? So yeah, this is the answer. Methylene blue, basically when it is oxidized, it is blue in color. When it is reduced, it is basically transparent in color. So this is the reaction. So that is why it is used as a indicator in many of the reactions. So basically you can see where you have glucose plus NaOH and then it reduces, so it is used for color changing type of reaction, but it is not directly used for glucose detection, because glucose detection you will not get per se color, you will not get a quantitative answer, you will get a qualitative answer, so you will get a positive or negative, but it is conjugated here. Glucose is conjugated with many of the secondary labeling antibodies, and then it is basically used for colorimetry detection when you need positive or negative in terms of detection of viruses or some of the other materials. So it is quite used in qualitative sensing, wherein you just need positive or negative answer. So is there any question? Okay, so we move to the last question. Here, this is basically on indium tin oxide. You have the primary and primary detecting antibody. You have protein PSA, which is the analyte which you need to detect. Then there you have a secondary antibody which has been secondary antibody which has been detected, which is to be used for labeling application. Then there is basically an entire redox reaction happening so as to increase the signal. So what we need to find out is what is the labeling element here. So what does M represent? So whether it is Ag, that is silver, Au, that is gold, ALP, that is alkaline phosphate, or APP, aminophenyl phosphate. So any guesses? Okay, even if you have not seen the lecture, what will be your guess? So I would request you to just take a guess and just attempt the question, because you need to know so how it has to be. So even if you don't know something, because it is very difficult to retain everything, so you need to understand the approach as well. So how you approach the answer, correct? So yeah, we have the answer. Yes, gold is basically used here. So you can see in this reaction, you are using amino alkaline phosphate is an enzyme. So for that, for the enzyme to actually take a reaction, it cannot do a reaction with a nanoparticle. Amino phosphate is basically a primary product, so it is not used for labeling application. So amino phosphate is gone. Alkaline phosphate is basically an enzyme for which you don't have a nanoparticle as a starting product. So again, that is also eliminated. So so you are left with gold and silver. So basically, silver is not very regularly widely used for labeling applications, uh, and because its surface modification chemistry is quite complex. So in this, gold is the most widely used material for as in labeling nanoparticle. So gold is our answer. So, any questions? So, we finished the 10 assignments for the practice assignment. So, those who joined in late, you can refer to the YouTube video, or you can even go through the lecture materials. Basically, I've given access to everyone. So, there was problem with the access last week, but now anyone with the link can just open the lecture materials and view them. So I'll upload this lecture slides by late evening or tomorrow, and you can go through them. So if in case you have any other questions, or if you want me to I'll just go through the questions again for the people who join later. If they have any doubts with that question, they can just unmute themselves and just ask the question. So this is a redox reaction. The first question, we just had to identify which are the starting materials in redox reaction. So we are given all the materials which are involved in this reaction, and we need to know what will be in the start. So basically, it's good that we have two questions we can do simultaneously. So in this lateral flow assay, we have the sample pad, then we have the primary labeling uh, uh, we have the part where the labeling is occurring. Then we have the labeling secondary antibody, and we have the detecting antibody. So primary detecting antibody. So in this zone, uh, in the labeling zone, what will be the mm, materials that will be used? So that is what this question is actually asking. So this is the answer for this question. So basically these are the starting materials that you have to put, and so basically you need to put TCP that will be reduced. So then ANGP, basically that if you can see is the starting material for the reaction to happen with the labeling elements, that is again a starting material. And the ruidium, basically it has to release a electron. So we have ruidium 2 plus, so basically it will release electron and it will come gain a higher oxidation state. Then in this we have to identify what is the correct lateral flow assay. So we have here 4 options. So we have to identify the lateral, which is the correct representation of a lateral flow assay. So basically you have to understand from the 3 electrode concept that all the detection will happen on the on the working electrode. So the primary detection antibody has to be in on the working electrode. So and again the labeling should happen before the sample actually undergoes. So for the redox reaction to happen, the primary labelers like the TCP or rudium are have to be present uh, in the sample when it reaches the working electrode. So in that case we need these. So the answer is B, because we have the primary detection antibody as well as the labeling before the sample reaches there. So when the sample reaches, it will have everything and then it will cause the reaction and you can detect the sample. So this is the very simple question: what are the common drawbacks of current medical diagnostics? These are the drawbacks. It's laborious, it requires a large volume, and it requires trained personnel. So that is something which is being tried to eliminate using point of care devices. Then you have to identify which is the correct redox reaction. So all the um, options look the same, but here you can see from the basic fundamental is that there has to be a release of electron at the electrode. So why we are having an electrode is to detect the electron that is being released. So a release happens in oxidation reaction. So the reaction at the electrode cannot be a reduction reaction, so it has to be an oxidation reaction. And since it's a redox couple, it should have reduction and oxidation both happening. So the answer is C. Then we had to find the abbreviation for this TCEP. So the abbreviation is trace 2-carboxyethyl phosphine, and this is the structure of TCEP. Then again, this is something which has been discussed in the class. So what is the redox couple for 4-nitrophenol? Then these are the two nitro couples, 2-hydrochloroquine and benzoquinone. Then the seventh question, basically in a glucose monitor, basically what happens, what is the reaction when glucose reacts with glucose oxidase, what does it form? So what are the reaction byproducts of the reaction we have to identify. So basically, as I discussed last week as well, what we are detecting is we are detecting the electrons. So it has a platinum electrode, then there is a semi-permeable membrane, then there is a glucose oxidase coating. So at the platinum electrode, H2O2 oxidizes into H2O, and it releases the electron. So what we are detecting actually in the home glucose sensor is we are detecting the hydrogen peroxide. We are not detecting glucose directly. We are detecting hydrogen peroxide at the platinum electrode. So that is the first byproduct, and then the other two byproducts are glucolactone and gluconic acid. So these are the three byproducts that are generated for after with the in the reaction between glucose and glucose oxidase. So then there is this reaction. No chemical name is being given in this reaction. So you need to actually look at the lecture where these structures have been discussed and remember them. So the answer is A and B. So when we have aminophenyl phosphate reacting with in presence of alkaline phosphate, reacting with alkaline phosphate, we get aminophosphate, and then aminophosphate undergoes some reaction, and then you get aminoquinone. So this has been discussed in the lecture. It's not there in the lecture slide, but it is there in the lecture. So I would request you to actually go through the lectures and look at it, because that might be important for your exam. That might be a decider in your performance in your exam. So please go through it. Again, this is a very fundamental but a tricky question. So in which form methylene blue is blue? So we have it basically in the oxidized state it is blue. When it reacts with glucose and NaOH, it changes to transparent. So that is how it is used for colorimetric detection through indirect methods. It methylene blue is used, and then there is the last question. So basically, what does M stand for in this example? So that is gold nanoparticles. So any questions? Any for the people who joined in late, I have done a brief revision as well. So any question regarding any of the question here? Okay, so basically from Divya's, I can identify that you are a PhD scholar. So can you just briefly tell what is your field of research? We'll just have a short discussion if we can help. you with some research papers or something, I'll try to help you with that. Others as well, you are free to ask questions, or you can just tell me what you need to, what is your research area or something like that, where you need help. We'll try to help you with that as well. Yeah, in case you don't have any question, you can just, yeah, I'll upload the videos also. This is assignment 2 basically. Assignment 1 video I've already uploaded, and the test and the materials also there in the shared link. Uh, so, so in case you don't have question, you are free to leave. I'll keep the session open for the latecomers. So anyone want, if you have something to discuss, you can discuss. In case you are not comfortable discussing, you are free to leave. for the latecomers, we have actually discussed the assignment practice assignment for this week, and we have basically the video will be uploaded on YouTube, and the um, slides will also be uploaded in the respective drive. So if you have any questions regarding the assignment questions, if you have discussed, if you have actually seen them, you can discuss. You're free to discuss. So for those joining now, uh, we discussed the assignment practice assignment 1. So if you have any doubts regarding the assignments, regarding previous week assignment or anything else, you can discuss by unmuting yourself. If you want, I'll just go through it again. I'll just go through all the assignment questions again, once again. So here we have the first question. Basically, what are the starting materials in this redox reaction? So then we have to determine what is the correct representation of a lateral flow assay. So in a 3 electrode setup, all the detection happens at the working electrode. So the primary detection element has to be on the working electrode. So likewise you need to find out, likewise you need to select the right option. So at the working electrode, the both the labeling reaction as well as the main detection reaction as well detection as well as the redox reaction should occur. So the redox material redox chemicals also have to be there. So that is why the correct option is option B. Then this is a very basic question where you find out what are the current drawbacks with current medical diagnostics. They are laborious, handling large volume, less time consuming, complex and single step, trained personnel, miniaturization. So the correct answer is they are laborious and they require large volumes and they require trained personnel. So then there's a fourth question. Basically, which of the following is a redox reaction? So you have to understand that the basic purpose of this set, the screen printed graphing electrode, is to sense the electrons that are coming out from the redox reaction. So and for the electron release, only oxidation reaction is there. Reduction is basically to take up electrons. So from that we can eliminate answer A and D, and then again it's a redox reaction, so it has to be a couple. It has to be reduction plus oxidation. So in this they are showing only two oxidation reaction, whereas here we have reduction as well as oxidation happening. So we have a redox couple as well as the electron transfer happening at the electrode. So from this we can find out this is the correct redox reaction. So we have to find out what is the full abbreviation for TCP. TCP is basically tris carboxyethyl phosphine. So this is a very important chemical, and you also have to recollect the chemical structure also. It is highly recommended. Then the question 6 is what is the redox couple for 4-nitrophenol? So basically the redox couple is basically the reaction on the oxidation of 4-nitrophenol. We get hydroquinone as well as benzoquinone. So these are the redox couples. Then we need to then the seventh question is what is the reaction of glucose with glucose oxidase forms. So basically in a glucose monitor we have the platinum electrode which has coated with a semi-permeable membrane, and then we have a glucose oxidase. So basically add on glucose so at the platinum electrode basically we have the electron release. So the electron release has to give out so electron release happens due to reduction of hydrogen peroxide and into and giving out electron at the platinum electrode. So what we are detecting in a glucose sensor is basically not glucose directly, but we are indirectly detecting glucose by detecting the hydrogen electrons from released by hydrogen peroxide. So the quantity of electrons released is proportional to the quantity of hydrogen peroxide produced is proportional to the glucose in the sample. So that is how it functions. So we have the three byproducts, so that is glucolactone, gluconic acid and hydrogen peroxide. So this is a reaction of aminophenol aminophenol phosphate with ALP. So what does it give? So it gives aminophosphate as well as aminophosphate then reduces to form aminoquinone. So again the ninth question. So, which form of methane blue is blue? So, the answer is basically in the oxidized form, methylene blue is it is blue. When it reacts with glucose or NaOH, it becomes colorless. So that is this property is basically used a lot in colorimetric detection. So colorimetric sensor it is widely used. So this is the reaction that is occurring. And in the last one, we have to identify what is the labeling element. So here we have M. So we have to determine what is the labeling element, which can so it's silver, gold, ALP, APP. So for ALP, the initial product is APP. So here ALP and APP are cancelled out. So silver EG is not widely used in as a labeling element because it is very difficult to control the surface reactions with silver. So the most widely used labeling element is gold. So these are the 10 questions which we solved today. If you have any questions regarding these questions, please ask those questions. Please feel free to ask them. Please use this platform to get your doubts cleared. So in case you have any questions, queries, please feel free to use this platform. There are not too many people, so don't feel shy as well. So please use this platform as much as possible. So there is nobody here, so I'll be waiting for whoever joins in late and give them a brief revision like I gave to all the others latecomers. that there is no one around, so I'll just wait around for some time for the people to, in case somebody wants to join in late. But I would like to thank all those who attended the session. I would like to thank you for attending the for being the part of this session. Thank you. Thank you very much. Um, for people joining in late, we have discussed the assignment, practice assignment 2 for this week. The video of the session will be uploaded on YouTube, and the lecture material will be available in the from the drive link. In case you have any questions, you are free to ask. In case you even have questions regarding the previous week assignments, that you are also free to ask. Any questions? So for the previous session, it has been uploaded. Because last time I couldn't upload it right away because of some technical glitch. I had to actually re-record the video. This time I am hoping that there is no technical glitch. So if there is no technical glitch, I'll upload it by tomorrow afternoon or tomorrow evening. And the lecture slides I'll upload it right away in the late evening. After the session is done, I'll upload them. So video, it will take some, like, tomorrow maximum. If there is no technical glitch, I'm hoping there is none today, because last time the recording didn't happen. It only recorded for 5 to 10 minutes and then it stopped, so I had to re-record it again. So this time I'm hoping that it will record well, and I'll upload it by tomorrow. In case you have any other questions regarding like week 1 content as well, you are free to you can ask. Yeah, I see that nobody is joining the uh, lecture, so I'd just thank you all for watching this on YouTube as well. I'd like to thank you. If you have any questions on YouTube, you can put that in the comment section, and you can ask in the next class as well. Thank you. Thank you for your attention, and see you next week.